All right, so special right triangles and the unit circle. Okay, so these are like my first and second favorite things all in the same lesson, okay? And that's like fantastic. All right, we know all about special right triangles. And this is the last time we formally introduce it, and then we all assume that you guys are experts on these special triangles. All right, so first off, we're going to talk about the 30, 60, 90 triangle. So recall what we talked about before. In a 30, 60, 90 triangle, there are two acute angles, right? So you've got one that's 90, and then those other two are less than 90 degrees. They're acute. So there is a small angle measuring 30 degrees, and a larger one measuring how much? 60 degrees. All this we already know. We also know each angle is opposite to a leg. The 30 degrees is opposite to the shorter leg. Okay. Its measure can be written as any number. We like the number 1 for the shorter leg. The 60 is opposite to the longer leg, and its measure can be written as how much? If the short is 1, then that is 1 root 3, so root 3, okay? Then the hypotenuse, Jake, will measure 2. Yeah, 3 and
x times 3.
Correct. So if we're here, we've got the 30 degrees, 60 degrees, and 90, and there's our 30, 60, 90. The shorter leg, is that the horizontal or the vertical? The vertical is the shorter leg, and that's the one with the size of 1, and that's root 3, and the hypotenuse is 2. So notice also, right, recall also that when we say the shorter leg is 1, that's just choice. I could have said it was like 57, but why 57 when we can do 1, okay? All right. So yeah, and then, so look at these triangles here. We don't always have to orient the triangle like that big one on top. It could be facing any which way, right? So in part A, right, if I wanted to write 30, 60, 90, then where would the 1 go?
On the left.
On the left, and 60 would go down here, and 2 would go here. All right? And so now, how much would the sine of 30 be? If it's opposite over hypotenuse, 1 over 2, and how much would the cosine be? Root 3 over 2, right? Okay, so what I want you to do now is do the same thing for triangle B. So now we're going to label the angles. Again, the 30-degree angle is going to be that smaller looking angle.
Wouldn't it be the same for every single one?
It would, wouldn't it? Okay, so that's the point of this, is that very quickly we figure out that, oh my God, it doesn't matter how you orient the triangle, the sine and the cosine of 30 degrees are always going to be the same. And so once we figure that out, that this is 30, and that's 1, root 3, and 2, then it's always going to be the same, right? Even for, let's say, triangle C, if this is 30, the opposite is 1, root 3, and 2. So sine would be 1/2, cosine would be root 3 over 2. Okay. Now, I want you to, now let's move on to here, 60 degrees. So in this case, if this is the 90, then here we have 60 and 30. And now where does the 1 go? Vertical or horizontal?
Horizontal.
Horizontal is 1, and this is root 3 and 2. So sine of 60 would be root 3 over 2. And how about the cosine? 1 over 2. Yes, they flipped. Okay. So here, if I've got 60 degrees here, root 3 faces there, 1 and 2. And so sine of 60 would be opposite over hypotenuse, and cosine of 60 would be 1/2. Okay, why do I do this? Why have I spent this much paper and this much time doing this? Let's think about, let's look at all these values now. I have sine of 30, cosine of 30, sine of 60, cosine of 60, and look at the values. It's the same values repeating over and over again. 1/2 root 3 over 2, 1/2 root 3 over 2. We haven't come up with any other values, right? Okay, let's look at those a little bit more closely. Between the 1/2 and the root 3 over 2, which one is bigger? And we can actually find that out on the calculator, right? So if I have the 1/2, I know that's a 0.5. And then if I have root 3 over 2, that's 0.866, right? So of these, the root 3 over 2 is bigger, and this is smaller. Okay? So think about that. So we only have two possibilities for sine and cosine of 30 or 60, and one is bigger and one is smaller. So here's how we reason it out even further. Look at 30 degrees. Smaller angle, right? It gets the smaller sine. Look at 60 degrees. Bigger angle, bigger value of sine. Okay? We're going to revisit that in a little bit. Okay. Let's do the 45, 45, 90. The 45, 45, 90 has two congruent acute angles. 45, 45, 90. And so they both measure 45. The 45-degree angles are opposite to congruent legs, and we write their measures as 1. So 1, 1. Then how much is the hypotenuse?
2.
Root 2. Okay? All right.
What is it? Is it x root 2?
Yeah. It's x root 2. Okay, so look here. 1, 1, root 2. So how much is the sine? If this is 45?
1 over root 2.
1 over root 2. And how much is the cosine?
1 over root 2.
1 over root 2. Oh my God, because they're like the same, right? And that happens because the legs are congruent. Let's do D, just because we haven't done a D yet. Right? This is a 45. Legs are 1 and 1. And hypotenuse is root 2. So how much is the sine?
1 over root 2.
1 over root 2. Okay? Okay. This is all nice and cute and all, but suppose, right? Suppose we wanted to rescale the triangles so that the hypotenuse is always 1. Right now, what do these look like? Right now, these look like that's a 1, that's a root 3, that's a 2. And here we have 1, 1, root 2. So in the first case, the hypotenuse is 2. In the second case, the hypotenuse is root 2. Root 2 is like 1.4. What if I wanted to rescale it so that the hypotenuse is 1? So like if you were working with this on Photoshop and you wanted to rescale it, right? Do people even use Photoshop anymore?
Yeah.
Okay, I thought it was outdated like everything else. So suppose you were going to do that, right? You just want to make it smaller so that the hypotenuse is 1. You still have to keep the rest of it in correct proportions, right? That means you can't just make the hypotenuse a 1 and leave those the same. You have to rescale them equally. What can I do to that hypotenuse of 2 to make it a 1? What can I divide by? Remember with like rescaling, we only like multiply or divide by number. So what can I divide by?
2.
2. I can divide by 2, but then I have to divide everything by 2, right? And so then what happens is this side becomes a 1, and the other two sides are 1 over 2 and root 3 over 2. Okay? Now what about the second one? What can I divide that by? Root 2. And I get this. Again, the purpose is now here I have a 1, and then the other two legs are 1 over root 2, 1 over root 2. Why do I care? Remember how we kept doing opposite over hypotenuse, adjacent over hypotenuse? If the hypotenuse is 1, and you do opposite over hypotenuse, it's just that. It'll just be that over 1, so just that. So now I don't have to do this opposite over hypotenuse business anymore. Like, how tedious was that? Okay? So let's leave that there for a minute and go to radian. I've sort of touched on this before. We know how to convert to radian, but then there are these special angles, the 30, the 60, and the 45. All right, do you remember 180 is pi? You remember this, right? Okay. So then 30 degrees, right? How much is that in radian? I don't want you to have to do it with the fractions all the time. You know, like times, fraction bar, conversion factors.
Wait, wouldn't that be pi over 180?
Well, okay, so here's how I do it. 30 degrees, right? What do I do to 180 to get 30? 1 over what would be 30 degrees? 180 over what gives me 30 degrees? So, yeah, in other words, what can I divide 180 by to get 30? 6, right? So since 180 is pi, then 30 is pi over 6. Okay? So let's think about the next one. It's 60. 180 divided by what would be 60? 3. If 180 divided by 3 is 60, that means it's pi divided by 3, pi over 3. So this is how I can quickly go back and forth between 30, 60, 45, and what pi over 3, pi over 6, pi over 4. 45 happens to be 180 divided by 4. So that's just pi over 4. So me, Miss Malikian, will always do, 60 degrees, that's 180 over 3, so that's pi over 3. 30 degrees, that's 180 over 6, so pi over 6. Okay? All right, questions? Okay. So now, take a look at this. We want to evaluate sine of pi over 6, okay? Pi over 6 is which angle, the 30 or the 60? The 30. If it's the 30, then look, with my rescaled triangle, this is a 1, this is a 1/2, and this is a root 3 over 2. Okay? So it's just 1/2. Because sine was always the opposite over the hypotenuse, now it's just 1/2. Okay? How about cosine of pi over 4? That's like the 45 degrees. And the two sides are 1 over root 2. So cosine would just be 1 over root 2.
Don't you simplify that to root 2 over 2?
You don't have to. You can. But remember, in trig, we don't have to do that anymore because we're older and wiser. And we are more privileged. Cosecant pi over 3. So So is pi over 3 30 or 60? 60.
How do you know that?
Because how do you get, what's pi over 3? Pi is 180 over 3 is 60. So now,
You showed a box.
so 60, this side is root 3 over 2 and 1/2. Okay, now cosecant, is that like the sine or the cosine? Sine. So we're going to take this and take the reciprocal. 2 over root 3. Okay. Pi over 6, which one is that? The 30 or the 60?
60.
30.
30.
30. Look at the 30, 60, 90 triangle. Remember we said you have a half and a root 3 over 2? Remember we said that's the smaller one on the calculator and this is the bigger? So look, small angle gets the smaller value for the side. Bigger angle gets the bigger one. So here, if this is 30, smaller angle, smaller value. Okay? And then this would then be root 3 over 2. So cotangent is adjacent over hypotenuse. Root 3 over 2 over 1/2. What happens to the 2's? They cancel, so we just end up with root 3. Okay? All right, unit circle. Okay, so a unit circle is a circle of radius 1. And the point of this is the special triangles from the top that we rescaled fit into these super nicely now. Take a look. So remember one of those triangles looked like this? 1, 1/2, and root 3 over 2. That's the 30. So look, if I'm at the 30 degrees, okay, 30 degrees, I make a triangle, boom, boom, 30 degrees. So between the 30 and the 60, 30 is the smaller angle, right? It faces the smaller side of 1/2. So this is always root 3 over 2. Okay? And now, what about the 60? 60 degree angle. 60 degree angle looks like this. So now, when I make this side, 60 degrees is the larger angle. It faces the larger side. So how much is that new blue side now?
1 over 2.
The 1 over 2 is the smaller one. That would be root 3 over 2. And this would be the 1/2. Okay? This is going to take some getting used to.
Do you need to memorize this?
No. I'll show you guys how to reason through it. Right now, let's explore and look at some of the patterns here. Let's explore and look at some of the patterns. Okay. So, first off, I have here 30 degrees. Okay? So from x-axis to angle 30 degrees, look here. This is also 30 degrees. But how much is it from beginning to end?
180. Wait, what do you mean?
From beginning to this blue terminal side,
Oh, 150.
150. Okay? And then the other one, that's the corresponding angle here, 30 degrees from the x-axis. How much is it from beginning to here?
210.
210. And then here, more 30 degrees, right? So from beginning to end,
Like to the reference
Angles would be
Almost, yeah, 30, yes. So from beginning to end, 330. Okay. Now look, students usually can get those, but it's the radian that we have more difficulty with. Okay. 30 degrees, that's pi over 6. Okay?
all the ones that were 30 with pi over 6.
Oh my goodness. Look at that. Uh-huh. Look at that. Look at that.
When we need a calculator or not, like when it says sin 120.
Most of them you'll do without a calculator for this.
How will we know when we need a calculator? Find exact values?
No, exact values is where you don't need a calculator, so that's how you know. Exact values are the fractions. Okay, so let's take a look here. This is pi over 6, right? It's 1 pi over 6. Now here's what we're going to do. We're going to increase the coefficients until we get the ones that don't reduce. So look, 1 pi over 6, 2 pi over 6. Do these reduce?
Yeah.
Yes, so we throw them away. 3 pi over 6. Do those reduce?
Yeah.
The 3 and the 6 reduce, so we throw it away. 4 pi over 6, they reduce, throw them away. 5 pi over 6, does it reduce?
No.
It does not reduce, so this next one will be 5 pi over 6. So then I have 6 pi over 6 reduces. 7 pi over 6 does not reduce. That's the next one. 9 pi over 6 reduces. 10 reduces. 11 pi over 6 is the next one. Okay?
So it's always going to be prime numbers.
It's always going to be the ones that don't reduce. Not necessarily prime, but like the ones that don't reduce. Right?
No.
Because with the pi over 3, you don't get it. Okay, so look at this one. The 60 degrees, look at how they look. So look, you have 1 pi over 3, 2 pi over 3 doesn't reduce, and then what's the next one? Not 3 pi over 3, 4 pi over 3, so here's a non-prime one. 5 pi over 3 is the next one. Okay? And then the pi over 4s, right? Again, 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So the ones that don't reduce. Okay? All right. Let's have a quick practice with that on the board.